Today we have discussed any convergent sequence in a matrix space is Cauchy. What is the definition of Cauchy sequence? The sequence is said to be a Cauchy if the tail of the sequence, that is the terms of the sequence in the last term, xn and xm types, which is always distance between these terms is always less than 2 epsilon, then it is called Cauchy sequence, right? So we have to prove that by taking any convergent sequence, we have to prove that this is the sequence which is Cauchy. It is true for every convergent sequence that is lies in matrix space. If it is lies in matrix space, any convergent sequence, that is it is Cauchy. Okay. Now suppose firstly we take that what we have given, xn is a convergent sequence in X. If it is convergent, then it has a limit. What is the limit? Limit is x. We let that x be its limit. For taking the limit, so we have the definition of limit, that epsilon is greater than to 0 and choose n is in natural number such that distance of xn comma x which is less than to epsilon by 2, right? This is the definition of limit for the convergent sequence, right? Now for each n is greater than or equals to natural number, right? Now if we have two terms n comma n which is always greater than or equals to n, so we have d of xn comma xm. We have to prove that it is Cauchy, so we take two terms of the tails of the sequence, right? This is xn xm, so distance between xn comma xm which is less than 2, distance between xn comma x plus distance between x comma xm. Okay, this implies that by matrix space triangle inequality property, right? This implies only for the matrix space triangle inequality property. That's why any convergent sequence in a matrix space is Cauchy, not in every space. It is convergent in a matrix space only. So this gives you epsilon by 2, this gives you epsilon by 2, that is the sum of these gives you epsilon. So xn is Cauchy sequence.